All right. So is it recording? Okay. So welcome to this class 5SSD0 or Bayesian Machine Learning and Information Processing. Unfortunately, it's going to be in a fully online class. Until last week, of course, our plan was to have this to have live sessions in the auditorium because of the latest lockdown constraints. Basically we were limited to 75 people, but we have 130 people in the class, so it would have to be a hybrid class where some people would sit in the class, the others would be at home, and then I don't know how they would be able to ask questions. So the decision was we're just going to have an online class. At least it's, I see in my screen there's a live transcription of what I say. That's really annoying. Okay, good. So what am I going to do today? I'm basically going to go through the logistics of the class. And I have two people I also want to introduce first. One is my co-instructor, Wouter Kouw. Yeah, I see you,
Hi, everyone.
Wouter. Maybe you can just say a few words about yourself, Wouter.
Yes, yeah. I'm an assistant professor in Bert's group. So Bert will be handling the lectures covering the theory of Bayesian machine learning and theory of probability and how to apply that to particular problem settings. And I will be handling the part involving programming, the probabilistic programming to be precise. These sessions will be interleaved with Bert's lecture, theory lecture. So Bert will explain something, then we'll go into a probabilistic programming session to try that out in practice, and then Bert will explain something new, and then we'll proceed onwards. There will be oh well, okay, that I think that's enough for now.
Okay, thanks. The other person is Magnus Kudal, who will be the TA. Can you shortly introduce yourself, Magnus?
Sure. Hi, everybody. I'm Magnus. I'm a PhD student in Bert's lab. And I'll do the final lecture on extracurricular cool things we can do with Bayesian information processing, and then helping debug and run various things in the background. So, yeah, pleased to meet you all.
Okay. I'm not sure if the recording is still going on. Yeah, good. Okay, so my name is Bert de Vries. I'm the main responsible instructor for the class. I'll do most of the lectures, particularly all the, let's say, theory and methods lectures. So Wouter will teach the programming lectures, and Magnus will teach in the end the bonus lecture on what is life. And that really is the title of the lecture, and it will be about what is life. Okay, I'm going to share my screen. Let's see if I could do that. I want to share the Canvas screen first. I hope you see Canvas now. This is let's see, just a second. I also want to see MS Teams while I'm presenting Canvas. Okay, so this is good. Okay, so you see Canvas here. We're not going to use Canvas. At least I don't use it a lot. As you can see, this is the how an instructor sees it, and all the items that we have here, and I crossed them all out. What you will see is this student view, and it doesn't even work. That's why I don't use it. Let's see. Okay, what you will see is just the announcement, people, and files. And there are 3 announcements. Takes really a long time, right, to load. 3 announcements. personally, I think the student administration likes to use announcements in Canvas, so we can't really get rid of it. But personally, I don't like Canvas very much, so we will be using another tool called Piazza, and I'll introduce that soon. Then the people, there are 130 people in this class. It's really slow, right? So it's a lot of people, and since everything is going to be online, I'm not going to meet you, at least I will only see your name. So I have a request. It's not something I can force you to do, but if you are, I would like to ask you to add a profile picture in Canvas. So we have a bit more of a feeling of who is in the class, and maybe if I meet you later in Flux, I may recognize the face, and I know that we can talk that you've been in the class, and I think that would be nice. Because otherwise, I will just see a name, and I will never even know who you were. I think that's a bit unfortunate when we do a class together. Because I also want to in this class for you people to work together a bit, and we'll get to that when I introduce Piazza. But this is really all we're going to do with Canvas. You can so you can see the other classmates here. And once in a while, there may be an announcement, particularly when it comes from the student administration. I want to go to the home page now in Canvas. And you may have read it already, but basically there are 3 links from the home page. And the first link is to here. Here they are. All materials for this class are available at the external class homepage. We have an external class homepage. Okay, here. We have an external class homepage, and I'm going to switch to that homepage in a minute. Then, like I said, all communication and announcements is organized at also an external page, Piazza site. And then there is a link to the syllabus, but that's just the basically the lecture notes for the first lecture. And you can also access that from the external homepage. So if I press here, then we go to the homepage of the class. Right. So this is the homepage. So it's an external page. I think you should bookmark this, because this is the page you will visit a lot, because all the materials in the class are basically accessible from the homepage. So I'll go through the homepage with you, course goals and course summary, blah, 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 blah. And news and announcements, we'll do at Piazza. Here are the instructors. As for books, everything is free. There are lecture notes, and if you want, there's a table here, and you can access the lecture notes online. For instance, pressing here at lecture notes B1. I hope, by the way, somebody can tell me. I hope you can see my my mouse. Yeah.
Yeah, we can see it. Yeah.
Okay. Cool. Cool. Okay. So if you would press here, you get basically all the lecture notes bundled in a big PDF file, or big. I think it's about 160 pages. It goes to GitHub, where it's hosted, and there's a download button. And the same for PDF bundle of all probabilistic programming lectures. And these two, the lecture notes and the probabilistic programming lecture notes, is basically the material for the exam. Everything around it is just supporting materials. Right? There's a book, very famous book by Christopher Bishop, Pattern Recognition and Machine Learning. You can buy a hard copy at bol.com or anywhere else. You can also click here, you'll go to Chris Bishop's site, and you can download a PDF from the book. And this is not really a book yet. Anthropic Inference Foundations of Physics. It all sounds very complex, and it has a lot to do with physics, but we only use a chapter on probability theory as background material. So the real thing that you want to maybe download, I think, is the PDF bundles. And well, since they're just PDFs, you might as well download these two. But I wouldn't really invest in buying the book unless you really want to go further in machine learning. Then we're going to be working with Julia as a programming language. And Julia as a programming language is a bit like MATLAB. It almost has the same syntax as MATLAB, but under the hood, it's very different. It's far more modern, and you could also compare it to Python. If you know Python or MATLAB, you're not going to have trouble learning Julia. But Julia is much faster. It is basically let's say the recruitment slogan is that it has the syntax of MATLAB, but it has the speed of C. And that they actually they're very close to that. So this is a very good programming language.
It's walks like Python, runs like C.
Okay, walks like Python, runs like C. That's the real slogan. Good. So I saw in Piazza there are some starter problems. Don't worry about it. The first lecture on probabilistic programming is on the 26th, so we have about 10 days to get that fixed, and we will get that fixed with you together, either in Piazza or we'll set up an online lecture to get it fixed. But so we will work on getting you set up in Julia, and so you can work on, so you'll be prepared when the probabilistic programming lecture takes place. Then the most important thing is that all materials for this class are accessible from this table. And the way, so here are all the dates, right, when we have lectures. This is basically the lecture topic. And what we do, and this is basically materials from last year, because last year everything was online as well. My intention was to do it basically to leave the lecture, the recordings of last year's online live classes on this website. But since we're going to make new recordings, for instance, this one, I decided basically in the last few days, I'm going to delete the recordings of last year. If you really want to see the recordings of the lectures of last year, they're still on YouTube. You can find them on YouTube. You can just go to Bias Lab, the Bias Lab YouTube channel. Bias Lab is the name of my lab at Eindhoven University. And if you want, I can also post a link in Piazza for you to find these old lectures. But really, you don't need it. What I suggest you do is for each lecture is before you come to class. Basically, you should be one class ahead. So before you come to class, you try to study the lecture notes. So if I press, let's say here, probability theory review, then I will get the lectures for the probability theory class. Right? It's a Jupyter notebook. It's online rendered. But like I said, we also have a PDF printout. So you can either do it to study it online. You can even study it on your phone because it renders very nicely on a phone. So here are the lectures, right? You can just go through it. It will show the math really well once it renders. You'll see some LaTeX in there that is not rendering right now, but in the end, don't worry, it renders really well. So you can go through this lecture, read the lecture, and if you understand everything, I think you're basically done for that lecture. Because that's the objective. I want you to understand the lecture notes. But what I advise you to do is before you go through the lecture notes, take a look at the video guide. The video guide is something, it's like usually about 20 minutes, an introduction to the lecture notes. rather than me going through every bullet or every slide in the lecture notes, I just try to pick out what I think will be some sticky points in the lectures, and I'll discuss those. And then I hope that with that video guide, it's just 20 minutes, you'll have an easier time reading and studying the lecture notes. I hope you have a better time understanding what I think is important in the lecture notes and what is, let's say, just background material. So my advice would be, let's say for upcoming Friday, the 19th, just look at the video guides at these are videos that are on YouTube. Just click and you'll go to YouTube. Then read the lecture notes. If you have time, try to make some exercises. If you click here, you go to exercises for probability theory review. If you click here, you see the exercise with solutions, right? So you can verify if you got the exercises right. At the same time, if you have any problem, post your problem in Piazza. I'll go to Piazza later. And then other students or myself or the other instructors, we can discuss your problem. And it's sort of an online Q&A forum. That the nice thing about it is that basically it's going to be there for the rest of the class. So when you study for the exam, everything that you put on Piazza is going to be there for you to study and for everybody, right? So that's why I would like you to post things there, any technical question for everybody to see, so that when I answer it, it's also for everybody. Then you can come to the live class with other questions, right? There may be logistic issues you want to discuss, or there may be other technical issues. And so it's a bit of a flipped classroom. I will discuss then your issues in the live class. We will record this live class. So Friday again, we're going to record the live class. I'm going to post that in here. There's going to be a link here. So slowly we will start filling up, the live class here with links of recorded sessions. So that's my advice. Read the video or watch the video guide, read the lecture notes, do a few exercises, write down your questions in Piazza, and if you have anything else, come to the live class. So the live class is optional. If you a lot of people have written to me that they have a conflicting class at on Friday or on Wednesday, and can they take this class? I think you can take this class if you if there's a scheduling conflict with another class, because basically all the materials will be online. You'll see a recording of the live class, you have exercises, you have the lecture notes, you have video guides. Any question that you have, you can pose in Piazza. So you have so many resources to study this class that I think it's not going to be dependent on you really physically attending these live classes at the hour that they are scheduled. So in principle, the class should sort of, you can also study it, I think, when we, let's say, when we're out of this quartile, because all the materials will just be up, right? So we'll do this. Friday we'll have probability theory, then we talk about Bayesian machine learning. Then Wouter will talk about applying that. So you get some exercises for writing code. We'll do that, we'll repeat that a few more times, 3 lectures, exercises with programming, 2 lectures and programming, then 3 lectures and programming, and then the bonus lecture. The bonus lecture that Magnus will teach is going to be about what is live. And like I said, it's really about what is live, but we'll do it, of course, from a machine learning viewpoint. Bayesian machine learning has a real connection to life, because, well, your brain is sort of doing Bayesian machine learning, and so we will make that connection clear, and Magnus will talk about that. And then on February there's a written exam. Are there any questions so far? Maybe you can, anybody who has a question, just raise your hand in MS Teams and I will answer your questions. Yeah, go ahead, Zhang or Heng Yang.
Yeah, so my question is, what's the constitution of our grades?
Okay, I will. So you want to talk about the exam and your grades?
Yes.
Okay. I will definitely talk about that today, but can I postpone that until after I talk about Piazza, because Piazza will play a role in the final grade.
Yeah, of course.
Yeah. Okay. Super. I will not forget that. Don't worry. Any other questions? Okay. Well, that's fantastic. So then I hope everybody is understands, let's say, how I recommend that you study for this course. Just go to this table and go through it in advance of the class and see the class as sort of a flipped classroom. Magnus, you have a question or a remark?
A remark. So just want to preempt a question that usually comes up towards the end of the course last time for all the other ones. The bonus lecture
Okay.
on life is not going to be part of your exam.
That's right.
Just,
That's right.
just to make that clear. So all the other stuff will be part of your exam, but the bonus lecture at the end is optional and is not going to influence your grade.
That's right. So this bonus lecture on January, what is life? It's just for fun. I hope you all attend. And I think the reason is by the time at this time here in January, we'll be talking about intelligent agents. And we think the ultimate intelligent agent is, well, the brain. And so Magnus will talk about that, but we're not going to ask questions about that at the exam. Thank you, Magnus. So then I think it's time for me to introduce Piazza to you. You can, there's many links to Piazza, but I also have it already open here in my browser. It should look like this to you. Maybe not with the green stuff here, but that's because I have an instructor view and a student view, and this is the student view, but it should look like this. So this is basically a forum where you can post questions and where questions will be answered. I'll go to Piazza of last year. So let's see. It's inactive now, but this is Piazza that we used last year in last year's version of this class. Just as an example. Right. So what we have here is there were 140 questions or let's say questions asked and 633 contributions from people. I'll give an example. Okay, let's just do something here. Interpretation of FE decompositions. It's usually not that slow. It's just because I have a really old MacBook and everything is running at the moment. Teams and I don't know. I see emails coming in and I'm recording, so that's why it's so slow for me. Okay. So here's a question posed by somebody, right? A student. I was wondering if somebody could help me with the interpretation of the 3 free energy decompositions. Then he pastes a GIF and he posts that in the class. The label is B12. This is the 12th lecture on intelligent agents. So there are groups in, so this is the first class. The second class will be on probability theory, Bayesian machine learning. So you can just go through all the classes. And then there's a student answer. And basically I invite any student to just write down an answer here, or collaborate on an answer. Students collectively construct a single answer, and then the instructor will just endorse this answer, right? I will just, now it says undo good answer here, but if I like this answer, I will just say good answer, boom. And then that means, okay, we take that as an answer, right? And sometimes there's a follow-up discussion. Sometimes another student says here, still don't get it, right? Okay, then we talk more about it. So there is a collaboration here on well, on making the material clear, right? There were 72 views, 72 students actually read this question, and a couple of students worked on the answers, right? The last update was by well, this guy Jules Vleem, and I can look in the manage class. I won't open it, but I can look who actually wrote the answers. You have an option to make your answers or even post your questions anonymously, so nobody in the class can see who, if you don't want to reveal yourself, but I can see it, and because I will use that as we will when we talk about the exam grade. But I don't think it's anything to hide. I think personally I would just yeah, just write what you think is an answer. There is no I mean, so I just want people to, I want to encourage you to help each other through Piazza, right? We can go through more examples, but it doesn't really matter. Every class, you see, usually there's about maybe 10 questions, right? That they're here about the derivation, what is the use of the trace, and okay. So now let's go back to our own class. Fantastic. Okay, so here you go. Yeah, so you can, at the moment we have out of 130 students, 92 enrollments. I would want to encourage everybody to enroll, because this is going to be, you will love this tool. I mean, all the reviews after last year's class were that this was really a fantastic tool. So everybody who hasn't enrolled yet, please enroll in Piazza. There's a link on Canvas and there's a link in the syllabus. So you should be able to find out how to enroll here, and it will really help you. You can just go to if you know a new post, right, and then you I think I shouldn't do it. It just goes too slow for me. Okay, so let's say you want to say have a question about Gaussian distributions, and you say yeah, summary whatever about Gaussian distributions, right? And you can use LaTeX. You can say well, let's do something cool. Uh, right, I could just write this. And here you will see on the right hand side how that is rendered. That should be, no, so you can do LaTeX, and you can also, of course, do plain text. Then you can say whether it goes to the entire class, or you can even write it to me personally. I will also use Piazza to do a poll in the class. In a few weeks, I'll do a poll and ask, how's everybody doing? Are you getting behind or not, right? I want to gauge, well, how's everybody doing in the class, right? So we're going to use this a lot. And I really want to encourage you to use it. So I'm going to kind of cancel this now because it's not a real question. Okay, so this is Piazza. Please use it. Then yeah, I'll go back to the home page, and then I'll talk about the exam. There are 2 old exams in the style in which this exam will be administered. The exam will be multiple choice. And if you press here, I mean, so we've done this exam 2 times let's say since COVID, we've done it 2 times, and both cases we've done it online. So a multiple choice. So here you get the exam. Yeah, in January in 2021, I had to split the exam in part A and part B. Because that's what the Delft ANS system, which is the tool we use, they wanted it that way. But it's just one exam, and here's the second exam. So there's 2 exams that you can just practice. The new exam will be exactly in that style. And I'll also tell you why you will pass this exam and how you will pass this exam. Because it's all multiple choice. And I'm not going to curve the score, which means that, let's say that for each question, I have 4 answers. So if you just answer everywhere A, you'll probably get something around like 2.5. That's just your for guessing, right? Then what we'll do is the final grade will be as follows. So, and I'll post it in detail later on Piazza, but there will be a programming assignment which will count for 1 point. The programming assignment will be assigned by Wouter somewhere towards the end of December. So you have the break to work on that. You'll hand that in and you'll do fine on the programming assignment. So you have your 1 point. And then we have a final exam, which is all multiple choice that will count for 9 points. So together with the 1 point for programming, you'll have 10 points. Now, on top of that, if your final score is going to be, well, if it's 5.5 or over, well, I will round to integers. So 5.5, between 5.5 and 6.4 is going to be rounded to 6. If it's between 5.0 and 5.4, then I'm going to look at your activity at Piazza. I'm just going to look at, okay, were you active in this class? Did you try to help other people? I'm going to give you credit for that. So that's very hard to quantify, but I'm going to make a subjective executive decision. Did I like what you did in Piazza? If so, I will upgrade your score to 5.5 and you will get rounded to 6. And this is why you will pass, right? Because that 1 point you go from programming is, you just work over the break and you'll just get your programming assignment done. You get 2.5 points for free, just from guessing. And on top of that, if you score, you only have to score 5.0 if you are active at Piazza. So you get almost 3.5 points for free, and you will pass if you score, let's say, if you are active at Piazza and you score 5.0. So you only have to do 1.5 points. That's why you're going to pass this class. And indeed, so last year, 87% of people passed this class. Now, that's not to say that it's an easy class. I think it is a hard class in a specific way. In this, it's sort of conceptually hard. But once you get the concepts, it's not going to be a very hard class. And so the examination, well, we're kind of mild there, right? It's multiple choice. You have all these mechanisms to crank up your score. So if you just work for this class and you try to keep up, you actually don't wait until the end, then I think you have an extremely high chance of passing this class. I'm not sure if it was entirely clear about the composition of the grade. Did I answer your question about the grade and the exam?
Yes.
Yeah, okay. Is that true for everybody? I mean, I will post it later, this story, so you can actually read it after. But is it clear for everybody what the final exam will be? So you want to get a sneak peek of what it will look like. Just look at these two exams. They are very representative of the final exam. They are more representative than the exercises here. These exercises are a bit older. I mean, I think they're still very good exercises for the class, but if you want to see representative exam questions, then you have to look at these questions, because these are multiple choice questions and it's going to be a multiple choice exam. All right, so basically this is more or less it that I wanted to talk about today. I will just in maybe 10 minutes, I will go really quick through the class, what it will be about, and I'll pinpoint some sticky lectures. So today was basically just course syllabus, machine learning overview, lecture B1. You can look at it, but there's, I think you'll be done in 15 minutes or 20 minutes. It's not, I mean, there's no equations. It's just, you're just reading. However, the word Bayesian is sort of a synonym for using probability. So what underlies everything that we do is probability theory. And so next lecture, and this is already Friday, we're going to review probability theory. This is unfortunately so early in the class, but this is, I think, the conceptually the most important class in the course. In one sense, everything that we will talk about in probability theory is this you've had in high school. There's nothing special about it. There's nothing difficult about it. It will be maybe a somewhat different view on these equations. We're going to take a Bayesian view, which means that we take probabilities, we interpret them as states of knowledge, of beliefs about propositions. But it's the same equations as always. So this is a very important class. So please, I mean, it's a bit rushed, but if you get a chance, it would be really helpful if before Friday you go through the video guides and you look at the lecture notes and you post your questions in Piazza, or you come to class Friday and we'll talk about probability theory. Then the 24th next week is actually also kind of an important lecture, because there we apply probability theory to Bayesian machine learning. In one sense, it's just a simple application of these equations to machine learning. But I have to say, in practice, you have to it's not going to be an easy lecture. It's a very fundamental lecture. So this is also an important lecture. So I hope the next week you have time to pay attention to what's going on in the class. Then it's going to be a bit easier in the sense that the rest are more or less applications of models. It's application, discrete data, multinomial distributions, regression, classification. Then at the end, almost Christmas, we have another fundamental methods class. So class 2, class 3 on Bayesian machine learning, and class 10 are methods classes. And these class 10, I think, is conceptually again a new step in Bayesian machine learning. We're talking about. Go ahead.
It's a Christmas gift from us to you.
Yeah. Okay, so this is a class you also want to prepare well for. Okay, then there's a large break, and then there's just more applications, and then we have the What is Life lecture. So my view is that classes 2, 3, and 10 are really the methods ones, and the other ones are more applications. So that's what I want to give to you before we start, so you kind of know that, and you also know that the next week will be maybe a bit dry, a lot of focus on methods, and you may not see the application yet, but that will come. So that's about it. So upcoming Friday, I think somewhere in the morning, right? We have another live class. What I want to do is, okay, we're going to start, and I'm going to say, well, are there any questions? You know, let's talk about it. And that's what, if you have 0 questions, we're going to be done in 10 minutes with that class, right? And so it's a class. The content, or at least the questions, have to come from you. Okay, I see another question. Heng Young, go ahead.
Yeah, thank you. I only used MATLAB and Python before. I never used Julia before. So, is there any way that I can practice or learn this language?
Yeah, so in the first probabilistic programming notebook, PP1, at the top there's a list of resources, and one of those is how to get started with Julia if you're already familiar with MATLAB and Python, and it focuses on the similarities. So how do you instantiate a vector? How do you create a matrix? And it'll show you a few things that are different, but basically it's a very short introduction to Julia, and with that introduction you're basically good to go for this course. You don't need any advanced Julia knowledge.
Sorry, can you repeat where it is again?
So Bert has it in view here. So if you go to this website, you'll see W1 Probabilistic Programming Intro Bayesian ML. If you open W1 the lecture notes, then at the top of the notes, you'll find a small list of resources, links, things that might help you in understanding the content of PP1. You'll see it here. There's a link, differences between Julia MATLAB / Python. So if you click that, then there's a small tutorial on how to get started with Julia if you're already familiar with MATLAB and Python.
Yeah.
There's also a really great video, Intro to Programming in Julia. It's a bit longer, but it highlights why Julia is a wonderful language and also a very useful investment if you intend to do software engineering as part of your EE career after your education.
Yeah. Okay. Got it. Thank you.
Yeah.
I think, by the way, you're not the only one. I think almost everybody in class will not have any Julia experience. So we don't expect in this class that you become a great Julia programmer. I think for the most part, it's fine if you can read Julia, and that will be almost as easy as reading MATLAB. And hopefully you can just, I mean, towards the end of the class, you can write really simple stuff, but we're not going to ask you to write complex Julia programs, because this is not a class about Julia per se. I mean, we introduced Julia because I think it's actually the machine learning language of the future. Not that Python will go away anytime soon. Python is a great language for machine learning, but it's also slow, and it's a really old language, and it wasn't really designed for machine learning. And Julia is. Julia is a very modern language where it actually has a lot of really great features relative to Python. And so I think the Julia will grow in the future. I don't think it will overtake Python, but it will grow, and it will be good to be familiar with it. And that's why we like to use Julia in our lab, for instance, because of its speed and all the possibilities you can do with Julia. So that's why we
trust us,
use
if
it.
you have Julia on your CV when you're applying, that's usually a big plus. So the first two probabilistic programming notebooks also, whenever I do something new in Julia that you haven't seen before, there'll be a short code note, and it'll explain what is happening there, and yeah, and if you don't understand a line of code or a piece of code during the probabilistic programming sessions, you should just ask in Piazza or during the live class sessions. That's what the live class sessions are for. And yeah, you'll be programming in Julia in no time.
Yeah, I see another question. Jibala.
Yeah. Hey, I just had a quick question regarding the programming assignments. So I see that there are 3 section of assignments. So would there be one deadline for the assignments, or are there like 3 separate deadlines for each of them?
Sorry, what do you mean there are 3 deadlines for?
No,
Oh, I think it's a misunderstanding. There will be only one assignment just before the break. These are just W3 and W2 are just classes on probabilistic
okay.
programming. So there will be an assignment just before the break, and somewhere after the break. We don't know an exact date yet. You can hand it in, but you get lots of time. But just one assignment.
Got it.
Yep.
Yep. Thank you.
Okay. Any other questions? All right. So this is I don't see. I see still your hand up, by Jibala, but I suppose that's from the
Yeah,
previous
sorry.
question. Okay.
Yeah, that was from the previous one.
All
Sorry.
right. No problem. Okay. So yeah. So from my viewpoint, this is what I wanted to say. And so we don't have to do a second hour from my viewpoint. I just wanted to introduce what we're going to do. And so it's a flipped classroom in the sense that I just point you now to the table. Try to study the probability theory lesson before Friday. Come with questions, put your questions in Piazza, whatever, and then we will spend Friday to discuss all of that. And if you miss it, then you'll see the lecture just appear with a let's say, or at least the recording thereof. You'll see it appear in this table, and you can just watch it afterwards. Then, yeah, I think if there are no more questions, then we're done for today, right? I also think it's that's good because these really late lectures. I mean, everybody's tired anyway. So are we good if we just close the session, or I'll give people a last chance to ask a question? So there's a question I think for Wouter to stay online.
No, sorry, I'm asking one of the students to stay online.
Okay, sorry. Okay.
We've resolved a few things with the software installation guide, but there's still an issue open, and I'd like to continue in the call so that we can discuss.
Yeah. So I won't end the call, but I will end the recording then. I'm gonna actually stop the recording now. Let's see if I can do that. Stop recording.